question 15 you're asked some questions relating to a surface which has the equation given here. The first question you're actually asked to do is a relatively straightforward one. You're asked to calculate the partial derivatives of f with respect to its two variables x and y. So we've got the partial derivative of f with respect to x. So in this particular case we get 4x minus 4y squared. We're also asked for the partial derivative with respect to y, and that gives us minus 8xy plus 1. So that gives us the first two partial derivatives. The second part asks us for the coordinates of the stationary points on the surface. So at a stationary point, both partial derivatives are 0, so they're going to be equal to 0. So this gives us two equations. So we get the equation 4x minus 4y squared is 0. I'll call that equation 1. We get minus 8xy plus 1 is equal to 0. I'll call that equation 2. So, taking equation 1, that implies that 4x is equal to 4y squared, which in turn implies that x is equal to y squared. So that gives us our first condition. Equation 2, that gives us that 8xy must be equal to 1. So now we've got our two conditions relating the x and y's so that we get a stationary point. So now we can make a substitution. So we know that x is equal to y squared here. So using that in this equation here gives the following. So we're going to use 1 into, so that's going to give us 8 times y squared times y is equal to 1. So that's going to imply that y cubed is equal to 1/8. Now because it's a y cubed, that means that y must be equal to 1/2. Now since x is equal to y squared, we've got that x must be equal to 1/4. So the stationary point is going to be 1/4, 1/2, and then we just work out the value of the function f at 1/4 and 1/2, which is minus 5/8. But for us, that's not important. So the stationary point is at 1/4, 1/2. Don't try and factorise out anything.